friends of SQL Bits. I'm Lindsey Allen, PM Director at Microsoft AI Platform Engineering Organization. After many years of speaking with you about SQL, I'm so excited talking to you about AI and machine learning. The topic of my session today is about powering new possibilities for every organization with Microsoft AI Platform technologies and tools that democratizing AI.
Hi everyone, that's my AI introduction. And I'm Lindsey Allen, and now I used to be in SQL organization for a very long time. And now I'm actually leading an AI customer engineering team in our AI platform organization. So my topic today is about AI, and looking forward to working with you on an AI project. So for most of our lives, people have had to adapt to technology. For example, to find a file on a computer, we type a command on a keyboard attached to one particular machine. To make a phone call, we type a seemingly random assortment of numbers onto a keyboard. To get a piece of information, we type a specific set of keywords into a search engine. Using AI, Microsoft is creating technologies that turns that dynamic on its head by creating technologies that adapt to how we work, communicate, and access information rather than the other way around. So there's many applications of AI. And for example, create virtual agents, and these are already out there, right? You see lots of virtual agents and combine bot and natural language processing, and research on self-driving cars, and machine translation, augmented reality, and e-commerce recommendations, predictive maintenance, and forecasting. AI combined with human ingenuity is already helping people to do amazing things. Thanks to AI advances, we can communicate more easily across multiple languages and even discover more personalized cancer treatment. We're still in the nascent stage of AI breakthroughs, and we can only imagine the possibilities of what people and technology will be able to do together. So there's a podcast, right, done by our director for AI research in Cambridge. And basically, there's two fundamental trends providing and fuel for these AI and machine learning advances. And in the so far, all the advances mostly are 99% of modern AI revolution of machine learning because AI general intelligence is not quite there yet. In terms of science, we've seen great activity in the machine learning area over the last 30 years, highlighted by the emergence of algorithms for pattern recognition and prediction, and availability of unprecedented streams of data coupled with drops in the cost of storing and retrieving that data. Large quantities of structured and unstructured databases about human activities and content have become available via the digitization and the shift to the web of activities around commerce, science, communications, governance, education, and art and entertainment. So the world's data is doubling every 2 years. More data created in the past 2 years than in all of human history leading up to this time. Then there's a computer power, and with cloud, right, a widespread availability of tremendous computing power available in the cloud to analyze the data. And the development of the cloud has been at the heart of delivering the huge increases in computing capabilities in this area. So to make what we do at Microsoft AI Platform is we want to make AI accessible to everyone. So that's why we created a set of services and tools and capabilities like cognitive service APIs and machine learning tools and that developers and customers and data scientists can use to add intelligence into existing products and services, or to build new ones. And we also developed the Onyx deep learning frameworks that's interops with all the popular frameworks and accelerate the training and inference on GPU, CPU, and FPGA. And we are using these advances in a number of ways already. We incorporated them into a product like Office 365, adding new capabilities that can help people work more efficiently and intuitively. We're also providing tools that developers can use to add AI into their products. And through offerings like cognitive services and machine learning, right? With that, let's look at the cognitive services. So cognitive services are actually encompass about 24 or more of a cognitive deep learning APIs, the REST API endpoint. These also, we call them pre-trained machine learning and pre-trained AI. And you can see this is the kind of eye chart, and group these models and by their areas: speech, vision, language, and the decision. Decision is a new cluster, incorporate reinforcement learning and anomaly detection and context moderation, and lots of advanced search capabilities. And the possibilities of creating application use this set of very powerful cognitive services APIs. It's almost endless. So let me show you just one example that's combine form recognizer. And form recognizer is to be able to extract like PDF file forms, like invoice, and into JSON files, into JSON data key value pair. And if you combine that with image recognition, and you can create, for example, insurance claim application. Let me bring that. See if I can bring this over. I've been playing with this before. Actually, I tried to record this a couple of times. I've been playing with this. So you can pick one of your image, right? For example, the car, and you think there's a crack. And you already took it to your favorite garage, right, to get it fixed. And let's pick one of the invoice from your garage. And now this little application will submit this together to your insurance company. So your insurance company now can actually look at the your image and the invoice together. And so what they will see is first, we use the image recognition to detect in this windshield if there's a crack. So now the computer vision image recognition says, see, we think this windshield have a crack. We made that determination with 92% of certainty, right? And the form recognizer and extracted the information from the invoice to JSON, and this little application formatted it in easier to read format, right? And so this invoice showing the that's how much the warranty deduction is, and the invoice total, and for fixing this windshield crack as $190.90. And with that, your adjuster or can decide to reimburse you. So this is just one example, and there's lots of other ways to use form recognizer and use other cognitive services to create your applications in robotics processing automation, or in many other applications. You can infuse AI and to modernize or do digital transformation of your business processes. So I want to share with you a real customer case study from one of our customer, Chevron, how they're using form recognizer in their RPA system.
Chevron has a long history of utilizing technology in our business. We need answers quicker than we used to and more complex answers. So we're turning to technology to help us with that.
Here in Canada, we have hundreds of rigs running, and every day that there is an operation, there's a report generated. We can see hundreds to thousands of reports daily. It's PDF data that is very complex. It's coming in many different types and qualities and structure, including tables that are embedded. So our current process is to take this big data from PDF and manually extract it. The time and resources it takes looking at data and getting that into a usable format is phenomenal. With UiPath and Microsoft, we've managed to work through the challenge dealing with data.
RPA is robotic process automation. It's about being able to take those tasks that humans typically do inside of a large enterprise and automate those on a highly repetitive basis. Form Recognizer in RPA allows us to be able to quickly take data from documents and convert it into a format that can be used for further business insights and knowledge management. One of the breakthroughs of the Form Recognizer service is its ability to just look at a small sample set of documents, then quickly take out key value pair information in a common standardized form that can feed back-end systems or data environments that are used for further analysis. We're deeply embedding the service in our platform to allow all different types of documents to easily be extracted throughout an enterprise environment. So we think that's key for making both our platform and our service capabilities extensible for our clients, as well as on a global level.
The prize isn't the data, the prize is what I'm going to do with the data. It just kind of makes me smile to think about what possibilities I could look at. With this technology, we can widen our aperture on our business and make decisions faster for sure, and help us to guarantee that we're headed in the direction we want to be as the #1 energy company.
So now if you want to create your own model, right? So the machine learning process is quite complex. It's lots of manual steps. Using different judgment based on the experience and skills of data scientists. Just say, this is just an example of a chart from scikit-learn and algorithm cheat sheets, right? So you already have all your data prepared and you did all your feature engineering, but the simple process, now you're actually ready to create a model. But now you have to go to pick the algorithm and a set of algorithms, right? And your favorite libraries and in that type of algorithm. And then you actually have to decide you might actually need more data, and you have to sort lots of things out. And this is like a repeat, right? Rinse and repeat and tune hyperparameter, and eventually you will get a model that's actually doing the job you want it to do. So if you look at a more clean diagram, you start with data preparation, which is quite time consuming. Sometimes we hear like more than 80% of machine learning is doing data preparation. And so you got your data prepared, you're ready to do your experiment. You can start with writing code with the Jupyter Notebook, with VS Code, or you can use tools like Machine Learning Studio, right? It's more interactive, low code or no code. And then you need to split your data. Then you start to do train and test and validate. Eventually, you get a set of models. You register models. You have to make a decision and which model you want to deploy into which application. And because based on the model performance, you would have to retrain the model, right? And so this is end-to-end process. Ideally, you want to have a tool, right, to assist you through this journey. all the iterative process. So we create Azure Machine Learning Service. What it is it's along that end-to-end life cycle, or actually it's more like circular, iterative. It's a set of Azure cloud services, and for each of this service, we have corresponding Python SDK that enables you to prepare data and build a model, train the model, manage the model, and track experiments, and deploy the model and monitor the model for you. So the basic workflow step for end-to-end lifecycle, and we have tools and capabilities and automations, and help you through the development lifecycle and deployment of machine learning. And since our goal is democratizing AI, we build Azure Machine Learning Service for all skills levels, right? And as you can see, this is homepage and of the Azure Machine Learning portal. And you can start completely manually from scratch. And you can start with a notebook, start to either branch out from a GitHub, one of the copy of the notebook, start editing it, or start brand new ones. Or you want to start with, say, no code, right? You can start with a designer. You can start with our machine learning designer. And what automated machine learning is, will help you actually automate the most time-consuming part, which is hyperparameter tuning and iterating through different algorithms. With the designer, and this is the second generation of Machine Learning Studio, and allow you to train and through drag and drop, and train and test prediction as well, all without writing any code. And the output, you can generate output through scripts, and you can actually deploy the model into a REST API web service. So this is fully integrated with Azure Machine Learning, and can automatically generating scoring files, register model, and build image and deploy to AKS. And the custom code run Python, both Python and R. So let me talk about this amazing capability called automated machine learning. And simply put, what this does is it automates the most time-consuming process of hyperparameter tuning and a different algorithm, testing different type of algorithm and models, and capable of generate ensemble models that have the best accuracy or best performance to solve the problem you want your model to solve, right? So it's really accelerating the model development, and loved by data scientists. My data science team loves it. I lead Azure customer engineering, AI customer engineering team, and my team of data scientists generally always give it a try, see what automated machine learning will do before they have to hand code everything, right? So you take input of your data, you define your goals, you apply constraints. The constraints could be accuracy, the constraints could be literally, I only want to spend 100 GPU hours, right? And it will create the models, whichever these models meet the criteria or the intermediate steps of the models, and all of these models are versioned and registered, and then you can choose a model best fit for your goal, right, to deploy. Let me show you how that actually looks like. Give me a second to find my, there we go. Back to. So first you create your machine learning workspace. Let me skip that. That's very similar to any create any resources on Azure. So then you go to your machine learning azure.com page. This is a workspace, right? This is Azure machine learning workspace. Will help you can like the home, show you what the home look like. This is what you saw in that slides, right? You can start with designer. You can start with automated machine learning, or you can want to do code first. Start with a Python notebook. And if I go back to, I decide to choose my engineering, submit, so nothing changes. I will go back to, this is my workspace. And if I want to start with automated machine learning, since I said I'll demo this, and I can start. So I want to create a new automated machine learning run or experiment, right? Of course, the documentation is conveniently located in this page. You can click on any link to view the documentation. And you started a run by, if you remember the slides, you need to tell what the data set to use, right? We can use existing. I loaded a bunch. You can create a new one. It's fairly straightforward. So I want to create from a data set from local files. And I just want to demo test 2. It's tabular. It's to support a different type of formats. Then it's just a test. I need to go find the file. Where is it? Car price, come on. There we go. So find it. Excuse me. Okay, it's parsing the file, parsing the data sets. Generally, I like to do validation, just make sure, right? And it realized it's a comma delimited CSV file. It's Excel, and have all these columns. I do have headers, and so it's just easier. I will use the headers, and I don't want to skip any rows. It's still loading the preview, and but you see. There's a couple of these the columns I feel like is irrelevant. I want to exclude them. You can exclude more, right? So I want to exclude these. And also there's things we need to figure this out is I want actually eventually I want it predicting a price, right? See, by default, data type, it didn't always get the correct data type. So I want to change the strings to just say integer. I don't really care about the decimal point of the price, and so I want to make sure the data type is correct. Then I don't want to do profile because it will take a while because I already have too many of those. So it will go ahead, see, there's create another one, right? So now if I actually want to go ahead from this, I want to actually just say I did not go create a new data set. I want to use existing data set. And I can create experiment. I can view data sets from here, which you already saw. And maybe just let's do existing experiment. So we load a new data set, just rerun the experiment. Maybe I changed something, right? And the output target column is the price. I want to predicting the car price. And when you create your workspace, you need to choose a compute cluster to run the training and also run inference if you choose to, right? You can create a new one from here. And you can also always go to Azure Portal to create a new one. Then if you hit refresh compute, it will show up in the drop-down list. And now this, you can see these are 3 default set of automated machine learning, each have many algorithms, right, for you to do. Since I'm trying to predict the price, right, I want to use the regression. And in regression, I think we support about, close to 50 different packages, algorithms. And Then I go ahead. So it's creating a run. It will iterate through different algorithms, and it's actually going to record each of output model, child runs, matrix for each, right? So if I just go back, to, I have too many. Okay, let me do this one. So with the predicting car price, and here you can include child runs for each, and you can add more charts to it, add a different status for charts, and I don't think I want to add any more charts. So give you idea, right, how to actually do deeper analysis of your different runs. And this is basically the measure accuracy, Spearman correlation, and this run took 23 minutes, 56 seconds, about 24 minutes, and have the best performance. It's the best run, so it's a choose by default for me. But if there's a 59, right, you can actually drill down to each individual one of it if you choose to, or just let's look at the best one here. And this is details of this run and the model and the algorithm's name, and the model registered with this long name, so you can find it. You can deploy this model, and that's the compute target used, right? You can view all the other. This default will show you, see, 93% accurate based on the Spearman correlation. You can see other different matrix and mean absolute errors, and root mean square errors, and the different normalization you can see, right? And so if we go look at the algorithms, the model actually created. So you can, of course, you can see more matrix. Then what I want to actually show you is, along with automated machine learning, we added a model explanation. So now we see with the car table, right? Car price table, you have lots of features or columns in there, right? The engine size, the peak RPM, the color, the doors, and lots of those, right? And you might actually want to know what actually is the most dominant feature make the price determination. And based on the LightGBM model and the prediction, actually calls out the engine size and the city mileage, MPG, and per gallon, mileage per gallon, are actually, this is the weight, I guess how big the car is, are actually most important features to determine the price for the car and how much you should sell the car for, right? And you can add more explanation if you want, right? It's then you can go ahead and deploy from here, right? You can deploy the model, give a name of deployment, and deploy. You can deploy to Kubernetes cluster, you can deploy to container instance, and you can click go ahead and deploy. I will not deploy this because it's going to take a while. And so there's other ways to look at this, right? So we have actually integration, native integration with Power BI. Power BI added the new capabilities called data flows. The data flow allow you to add the AI models, right? Machine learning models, both cognitive service and the custom models we just created. I just created, you see, in your the schema as a enhanced column. And so the car price flow and is what I added to. So this is the car price, the data flow, and have basically pointing to same files, right? And here you can set a refresh frequency, basically retrain and update the model. And if I click on edit entities, it will go in there, actually show how to display the car price as a enhanced column in this Power BI table, and basically this is calling Azure Machine Learning car price to predict what the car price should be, and you can compare that to the existing price, right? So this is the existing price. It could be recommended by whoever priced it, right? For the first car, I think it was a Alfa Romeo. Oh, the both top are Alfa Romeo, and you can create a dashboard from this, obviously. And the two Alfa Romeo, the first one is priced at 13,000. And the obviously AI actually think both cars should be have the same price, but you see the price are quite different. Whoever's selling it, 13,000 and 16,000, and AI actually based on the engine size and the weight of the car, and actually recommend the same price through the model explanation, right? And if I click on this, that's actually show you how to add the different. You can add another model to it, so add another enhanced column. Because I have lots of this was scanned through all the model I have access to and the list here. Since I have lots of models, this is going to take a while to expand. So let me switch back to the slides, and maybe we'll come back later to look at this the interface when finish loading. And so in this is what show you, right? In Power BI, we integrated many AI capabilities in Power BI. So it's very intuitive. It's no code. You can just use it directly, right? And from natural language query and to added these cognitive service APIs, key phrase extraction, sentiment analysis, and you can explore different predictions. And you can create a machine learning model directly. This is the interface from Power BI to call AutoML, automated machine learning, to you can create classifications, a binary or general classification, and different regression models, and you can do forecasting, create forecasting models from Power BI directly. Let me go back there, see if it's finished loading. Give me 1 second. Okay, it did finish loading. So so these is all machine learning models I have access to, and some these models you can show all parameters, required parameters. Let's go to the car price. This is one we only show we showed all parameters, right? These are the features we use to train the model, and so you need filling in all the ones with red asterisk, and stroke, just I use the engine type, and after this you can apply, and it will create an enhanced model like this one, an enhanced column like this one, AutoML, and a prefix with AutoML, and the car price is the model name, and save and close, and then you can use it in your Power BI applications from this point. So that's a wrap up my demo. Back to the slides. And obviously what I showed you is like a very simplified way of using AI in application. And in real life, you can create very complex applications or infuse AI in very complex applications, both in the cloud and with IoT, right, on the edge device. Let me show you. This is my team, AI customer engineering teams, working with Azure Stack and working with London Heathrow Airport on create a end-to-end solution to prevent trafficking of illegal animal parts. And this is a snippet from Microsoft Mechanic video.
At London's Heathrow Airport.
So the Azure AI customer engineering team, supported by the Microsoft AI for Good program, is working with Heathrow on a pilot to crack down on illegal wildlife trafficking, which today is a $1 billion industry. And what you can see here on the screen is a room at Heathrow Airport filled with some of the items that have been confiscated over the years. And whether that's from animals such as rhinos or leopards, which are sought after for their body parts, or animals that are becoming endangered, such as pangolins, considered medicinal and a delicacy in some cultures. And right now, today, the UK Border Force typically profile passengers based on flight routes that they may be taking, which are known for trafficking, before going on and searching their bags.
Got it. So it sounds like it's pretty manual and not a scalable way about doing things.
Exactly right. And in fact, even when luggage is scanned using powerful 3D X-ray technology, it's actually pretty hard to identify these illegal items. So for example, what I've got here is a raw scanner image, and you can see that there's a large object in the bag, but it really requires an expert to decipher what it really is. So they want to be able to use machine learning to be able to do the initial detection leading to a bag search by the agents.
Okay, and I can imagine it would also cut out a lot of the time that you would also take in terms of going through all these different images, and it would optimize that process, also given just all the sheer magnitude of bags, the thousands of bags that are going through at peak periods in the airport. But how are they looking to potentially use technology then to address the problem?
So the Azure AI customer engineering team has been working with Heathrow to build a solution comprising 3D scanner combined with AI models created in Azure, and they're running those models locally on the Azure Stack Edge. So here's how it works. Once the luggage passes through the baggage scanner, it produces a 3D VTK image file. And this is open source technology. It's the same tech that's used for CT scans in hospitals. Now, each scan's about 50 meg in size, and the scanner saves that VTK file to its local storage. Now, at the same time, we've deployed the Azure Stack Edge for local compute, and this has got 4 containers: sync, pre-processing, model, and broker. Every 200 milliseconds, the sync container copies new scans from the X-ray scanner to the Azure Stack Edge device. The pre-processing container rotates the image into different angles, and it also filters the image based on particle density to filter out objects that are out of our range of interest, such as high-density objects like metal or low-density objects like clothes. Now, we're looking for bones, and this has a medium density, so we can quickly detect organic matter. The model container then runs an AI model to investigate all the objects that have particle density similar to bones. Now, like a zoologist, it's been trained to determine that it's definitively a skull of the type we're looking for, rather than another object that might be mistaken for a skull. And once the model has made its verdict, the broker container manages the communication among the other containers, all on that Azure Stack Edge device. The AI model's verdict is stored in an output folder, which is continuously synced with Azure Blob Storage. And we then use an Azure Logic app to update an Azure SQL database with the results. And this can then be read by an airport agent on their mobile Power app to notify them of the likelihood of a positive match so that they can then go and investigate further. And this whole process just takes a few seconds.
Okay, so what was the
So let's just switch gear a little bit, and let's talk about responsible AI, responsible machine learning tool sets. So for now, AI is very good at doing certain tasks, like recognizing photos or words, but it still can't beat a baby's ability to understand the world around her through a combination of sense, such as touch, sight, hearing, and smell. As we make progress towards artificial general intelligence, in which AI starts to understand the world in a more sophisticated way, we need to make sure that we balance intelligence with other talents humans use to make good decisions, such as empathy and understanding. So we can and don't want to put the brakes on the speed of AI's progress, but we do want to make sure we're advancing the field in a responsible way. The people who use AI tools should be able to understand how they work, what data they rely on, and what steps can be taken to protect individual privacy. These AI advances should be as inclusive and biased as possible. Throughout the development and use of AI systems, trust must be at the center. Trust in the platform, trust in the process and trust in models. We just released a set of, during the build, right? In May, we released a set of responsible machine learning tools that encompasses and assists responsible machine learning values and principles. Understand machine learning models through interpretability and model explanation. And we have a FairLearn kit to help you assess and mitigate the potential unfairness and fairness in the model. And we have a set of privacy and data privacy toolkit to prevent data exposure using differential privacy, and also enables the homomorphic encryption computation to do machine learning with encrypted data. And third is to control the end-to-end machine learning process through documenting the machine learning lifecycle with data sheets. So the talk about the fairness in AI, right? There's many ways that AI system can behave unfairly. For example, a voice recognition system might fail to work as well for women as it does for men, just because there's more data or voice recording of men speaking. And another example is a model for screening loan or job application might be much better at picking good candidates among white men than among other groups. It's the same thing because the data volume, and machine learning is learning from data, right? The data volume is more biased towards different groups. So with the FairLearn toolkit and also the feature in Azure Machine Learning has two parts, right? First, use the common fairness matrix and with the interactive dashboard to assess which group of people may be negatively impacted, right? And then the second step is to use state-of-art algorithms to help you mitigate the unfairness in your classification or regression models and without actually sacrificing your model's performance. So in order to protect the privacy, and we have the joint research with Harvard University and create a toolkit and integration in many of our platform systems called Differential Privacy Toolkit. And this set of tools create privacy models, right? And put it in front of your privacy data sets and use machine learning algorithms and to actually help hide, introduce, like white noise into your data. It's not actually changing the data's distribution statistics, but hide the privacy of individual contributor to the data sets. This is especially important for data sharing in medical research and in the financials for anything like potentially the privacy, the data privacy is super important. So, so the future of AI, right? Next generation of AI. There's lots of work being done towarding general AI, general intelligence. The key of it is technology-wise is transferred learning. Basically, allow you to build upon the very large comprehensive model. And so it's just like, you teach a 10th grade or teach a kindergarten, teach 10th grade probably a lot quicker than teach a kindergarten student to write a Python program, right? And then there's lots of work being done, advances being done to build these very, very large pre-trained self-supervised network models. And our work on Turing, our largest Turing model have 17 billion parameters. and our partnership with OpenAI and created GPT-3 with 170 billion parameters. These are very large pre-trained neural network model, can be easily fine-tuned to learn specific domain knowledge to work on specific domain tasks. And then the culture shift on responsible AI and how to actually responsibly utilize the AI technology. So these large, very large models require lots of compute power, lots of storage to train. That's why we want to make sure, not only very few be able to leverage these huge resource demanding tasks, right? So we actually put AI Supercomputer on the cloud in Azure, be able to make sure we have AI at scale for everyone.
We've been building increasingly powerful systems for AI for a while. Late last year, we completed work on our first AI supercomputer and handed it over to scientists and engineers to start using in their work. The site top500.org keeps a list of the world's most powerful supercomputers, and I'm excited to announce today that our cloud-hosted supercomputer would make that list. By our measures, it's one of the top 5 largest supercomputers in the world. It uses 285,000 CPU cores and 10,000 GPUs connected with an extremely fast network. This machine is purpose-built for the kinds of massive distributed models that Lewis talked about earlier. That gives this supercomputer all the benefits of a dedicated appliance paired with the benefits of a robust modern cloud infrastructure. One of the most exciting things about this machine is that it's cloud-hosted. It's Azure. So because of the power of the cloud, we were able to develop and deploy this in just 6 months. And because it's Azure, it benefits from our carbon neutral commitments as a company. Let me step back for a second because I'm sure there's at least a few of you out there right now who are saying, well, it's pretty cool, but I'm not exactly in the market for one of the world's largest supercomputers just this minute. The work that we've done to get here has a clear benefit to any Azure customer. Our advances in large-scale clusters, industry-leading network design, and a software stack to control it all are applicable to the Azure product roadmap. A good analogy here might be the way automotive technology is pioneered in high-end racing before making its way into the cars that you and I drive every day. Hybrid powertrains, all-wheel drive, ABS, and more. Except in this situation, developers get the benefit of the output as well. Through the large ML models hosted on this supercomputing infrastructure, this new kind of computing power is going to drive amazing benefits for the developer community, empowering a previously unbelievable AI software platform that will accelerate your projects large and small. Just like the ubiquity of sensors in smartphones, multi-touch, location, high-quality cameras, accelerometers enabled an entirely new set of experiences, the output of this work is going to give developers a platform to build new products and services. Having access to ubiquitous, high-quality language translation, understanding, summarization, and reasoning is going to help supercharge developers. It will increase not only your own productivity, but also the capabilities of the products and services you develop.
So with that, I would like to wrap up my session. We know that advances in AI presents both opportunity and challenges. We're entering uncharted territory and making decisions we've never had to make before. Still, we're optimistic about the future of AI and about the ways AI advances can solve many more challenges than they present. Our goal in developing AI technologies is consistent with our company mission to help every person and organization on the planet to achieve more, we believe AI technologies have the potential to amplify human ingenuity in ways never before possible. Exactly how is only limited by the power of our imagination. As the computer scientist Alan Kay said, the best way to predict the future is to invent it. So with that, thank you for your time and attention, and I'm looking forward to invent the future with you.